Hello everybody and welcome back to Schedule Management. So now that we've planned the schedule management plan, and we've defined activities and we sequence them, now we want to look at the dependencies which help us to sequence them. So remember, so the dependencies have the following aspects. There's a mandatory dependency, which is often the work we're doing, that I have to lay concrete or frame a house. It's hard logic. A must happen before B. There's also discretionary dependency. These are often considered best practices or sometimes called soft logic. It doesn't always have to be that way, but you know what? In general, we found that this was the best way to do it. And the order does matter because it helps reduce risk. Then we have external dependencies, which is something imposed on us from the outside. And internal dependencies are imposed on us from the inside, such as a control mechanism or a boss. Now, dependencies and relationships matter, but they aren't the same thing. So I just went over dependencies: mandatory, discretionary, external, or internal. I give some examples there. And those dependencies, you must determine dependencies in order to use the critical path analysis, which will be used on a certification exam, and Rita's book will talk about it at length. And they're going to translate then dependencies into relationships, and there are 4. Finish to start, which is the most common, and you will do the math on the exam. Rita has some examples. Finish to finish, start to start, and start to finish. Those are the relationships that you'll have in the exam. Start to finish is least common. Examples are hard. So the activity dependencies, I'm still talking about it. Remember, most common is the finish to start. The top at the bottom is most rare, which is start to finish. And I give you a picture of each. So finish to start, look at the definition on the right at the top. The successor can't start. See the successor there in blue with the white font? The successor can't start until the predecessor is finished. And that's how life generally is. Finish to start. I must finish the predecessor before I begin the next activity, the successor. So when you had to wake up this morning before you could go to work, you must finish one before doing the other. Then there's start to start. So the successor at the bottom of that example, the middle of the slide, the successor can't start until the predecessor has started. Once the predecessor started, the successor can start. And I give examples there. Finish to finish dependency. In this relationship, the successor can't finish until the predecessor starts. So you see the predecessor, until the predecessor is finished, rather. The predecessor wants to finish, and the successor can't finish until the predecessor does. Then there's start to start, which is the picture there, and the successor can't finish until the predecessor starts. Okay? So there you go. Dependencies and relationships and how they are tied together. Okay? 2 activities can have logical relationships at the same time. They can start finish to finish, and also start to finish. There are examples of that. I think that's beyond any exam at our level. And closed loops are not recommended in logical relationships. So closed loops often happen in mathematics or in computer language, where things will loop and loop and loop and loop till you get the right answer. Closed loops aren't really recommended in these logical relationships. They're just, frankly, straight line dependencies, relationships. Okay. So now with these and a couple other tidbits, I'm going to be able to draw my network diagram. Remember that network diagram took my activities and put them in a logical order. There are no times yet associated with it, no durations, but I had my logical order. So the project network diagrams are the preferred technique for showing the sequence of activities. Be aware of leads and lags. If you change the relationships, which are generally finish to start, the most common, if you change the relationships, you can put in leads and lags as you develop the schedule. Okay? So what is a lag? A lag is a directed delay in a relationship. So say I want to add 3 days of delay, okay, between activities. And the language, the nomenclature is FS, finish to start, plus, in this case, 4 days in the picture in the middle of the slide. I've added 4 days from day 13 to day 17 between activities. And though I've added days, finish to start plus 4, it's called a lag. It's a directed delay. Then there are leads. Leads accelerate activity relationships. So there's an acceleration. So if you look at the picture at the bottom of the slide, I had a predecessor and successor. They were supposed to go finish to start. But now I have to lead it. So I will start it sooner. I will accelerate it by 3 days in this example. And so finish to start minus 3 is leading it by 3 days because I'm subtracting 3 days from my original start date of the successor. So an example of that is I'm going to pave the whole road 2 miles, and then I'm going to paint the road 2 miles. As soon as I'm getting halfway done with my painting, the weather says, hey, there's a hurricane coming. Oh my gosh, what can I do to finish this part of the project and tuck the material and personnel away and keep them safe? Well, the best practice is to pave the whole road, let it cool for a day, and then paint it. I'm making this up. I'm not a construction, but this is how the logic works. And then, but engineering says, but it's possible to start painting without any damage to the road or the paint qualities. It's possible to paint 4 hours after we're done paving. So what I'm going to do is accelerate the paving, even though I was going to pave the predecessor and then paint the successor activity. Now I'm going to accelerate the paving and start on it even before I finished paving so that I can finish this part of the project and put everything away before the hurricane. And that's all for this lesson. I look forward to the next one.